Now we have to derive the expression for critical damping coefficient. And for a linear system, the formula for critical damping coefficient Cc is given by 2 square root of k multiplied by m, or it is 2 m omega n Newton second per meter. And for torsional system, it is given by, in place of k, we have to replace k by kt and m by I. Here also in place of m you have to write down I and omega n as it is, and the unit is Newton meter second per radian. So let us derive this particular expression. So for critical damping coefficient, the condition is that if you remember the roots S1 and S2, then you can say that square root of 1 minus 4km divided by c square. If that value is 0, then the roots are same. So squaring both the sides. So if you square this term, then square root will go. 0 square is 0 itself. So we can say that 1 minus 4km divided by c square is equal to 0. Transfer this negative term on this side. So it is 1 is equal to 4km divided by c square. Cross multiply by this c square to this 1. So 1 into c square, that is c square. So c square is equal to 4km. Take square root on both the sides. So c will be equal to 2 root km. So this is the value of critical damping coefficient. So the value of damping coefficient obtained by putting square root of 1 minus 4km divided by c square is equal to 0. Whatever the value of c that we obtain is known as a critical damping coefficient. So for a spring mass system, if x double dot plus k by m x is equal to 0, and if you compare it with x double dot plus omega n square x is equal to 0, then we are having omega n square is equal to k by m, or omega n is equal to square root of k by m. So this we already know. So cc is 2 root km. Now what we'll do, we'll do some mathematical adjustment over here. So 2 as it is, square root of, now multiply by m and divide by m. So we are having, so this k by m is nothing but omega n square, and m multiplied by m is m square. So again try to understand this step. So this km we will keep it as it is. So you can see this km. So this is k and this m as it is. Multiply and divide by m. Correct. So this k by m is nothing but omega n square. So that we have substituted, and m multiply m by m, that is m square. So cc will be equal to 2 as it is. Square root of omega n square and m square is m omega n Newton second per meter. Now let us call this as our equation 1 and this as our equation 2. Now for a linear system, we know that c will be equal to 2 root km. So 2 as it is, it is also equal to 2 m omega n, that we have already seen. Now for torsional system, we can say that this T for torsional system, 2 as it is, square root of, in place of linear stiffness you have to substitute torsional stiffness. In place of mass, it is replaced by mass moment of inertia. Here also 2 as it is, in place of m it is I, and omega n as it is. So these are the representation of critical damping coefficient. The units are Newton second per meter for linear system, and CCT will have the unit of Newton meter second per radian for the torsional system.